Swayam Prabha. Digital India. Educated India.
If you can go for the resources section, you have interactive tools where you can calculate your personal and extended water footprint calculator, and there are different assessment tools, and there is also a lot of publications that have been grouped under one hub with respect to water footprint. So we wanted you to explore all of that. So all these problems would ponder on each of these sections. In India, it is 0.18 meter cube for every kilowatt hour. For point 2, it would be 1080 liters. And whereas in Germany, for the same cost, for the same usage, it would be 180, 1 by 10th of what it is in India. So we are here calculating only the blue and the green water footprint. Why not gray? We were seeing yesterday what green water footprint means, what blue would mean, what gray would mean. So why did we account for green, and why would we account for blue, and why not for gray, and why blue and green? Green we were discussing yesterday that would be associated with agricultural produce. So because we also were thinking of electricity being produced from biomass. So here we have 0.18 meter cube of water being consumed for every kilowatt hour of electricity generated in India, and whereas in Germany it's almost 0.03 meter cube per kilowatt hour. Why such drastic difference? We were talking about this during our energy sessions. What makes the difference between India and Germany? Why is there so much of water here and not much there? Yeah, we are mostly dependent upon coal and thermal water power plants, which uses a lot of water for, uh, yeah, cooling. That's the reason. So it's not the same if we browse the internet here in India and here in. We have negative externality. So that's about question 1. Coffee from different countries is the next question. An urban consumer in India drinks 1 cup of coffee every day, 150 ml each day for a month. Same person sitting in Brazil also does the same job. So what is the water footprint of coffee in Brazil versus India? So here, if you go to the website and not the link that I have shared, so you might have to head to resources and then interactive tools. So you would get to the water footprint assessment tool. You have various options over here, country, world, rest. So I'm going to check in for a particular country. Here in this case, it's India. Yeah, next. And then here you see the options of crop. So for India, I'm selecting a crop, agriculture, select a specific crop, coffee, close. The various representations. So I'm going to this tabular thing and then find coffee. Yeah, here it is. 3.5 into 10 power 9 meter cube per year. That's how much of water that's India is spending on coffee plantations. And you also see the bifurcation for green, blue, and gray water. Similar exercise, you can do it for Brazil as well. So the link that you have there, it will directly take you there. But if you want to use the tool, you can go to home. So we are looking at India and Brazil, 2 countries, right? So you can look at the country-wise data. India. So this would give a comprehensive database of the water footprint of India. So we can just scroll down to find coffee. Yeah, here it is. This is for India. The same exercise you can repeat for Brazil to find out the water footprint in Brazil. Yes, you have to go to waterfootprint.org, and then in the resources section, you have to head to water footprint assessment tool. The link that I have put it in the sheet, it will directly take you to the tool. But if you want to explore the website, this is the way. So this is the outlet. This is how the water footprint tool. Yes. Yes. The other way of doing it is you can head to the world section and then select a particular crop. Or you can just head to the world section on the water footprint assessment tool, where you can select the crop as coffee, which would give you this figure. So if you see, this is the total water footprint of coffee from Brazil. It is 21 into 10 power 9 meter cube per year. And then if you find the India, it's 3.3 into 10 power 9. And this is the bifurcation. So what do you think is sustainable coffee? Is it to have a coffee in Brazil or to have a coffee in India? Okay, there's a catch here. Did you look at the units? If you look at the green, blue, and gray before we talk about the units, which component contributes to most of the water footprint? Where is there so much of difference between India and Brazil? What does that indicate? Blue is the amount of water that we are taking from the surface and the groundwater resources. So, which means if you have been to Chikmagalur and the other places which are rapidly growing coffee, that's in a terrain where most of the crops are rain fed and not irrigated. That's why the blue water footprint of coffee from India is 0, whereas from Brazil it's 340 into 10 power 6. And we just cannot compare apples to oranges, right? There's so much of difference. The same crop in different areas cannot have so much of difference. And why is Brazil on the higher side? So it's because Brazil, the climatic conditions are so positive about coffee and they grow a large quantity of coffee. And as of 2024, the Brazilian coffee production is 3.98 million tons per year. And whereas in India, it's only producing 0.36 million tons. So this water footprint that we are talking about is for a country. If we are taking a country as a whole 100 pointer and how much each crop or sector is contributing, that's what we are looking at. That doesn't mean that Brazil is on the water negative side of coffee production. India is on the positive side. We should look at how much coffee is being produced in Brazil, how much produce is being produced in India, and then multiply it with the tonnage. So if you do the math, if 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 we are thinking that this data is from 2024, almost 4 million tons is being produced in Brazil. So 421 divided by 4 would be somewhere approximately 5 into 10 power 9. And in India, it's 0.4 will assume for, so it is 10 into 10 power 9 meter cube per ton. So what is sustainable coffee now? To have it in India or to have it in Brazil? Yeah. So when we are picking the data from this website, we should be very much cautious about what this data is representing. This doesn't represent the per tonnage water usage, but per year for a country, what is the contribution from each crop or the sector. So, and but Brazil, if you look at this, the coffee crop is consuming most of the water footprint. Even if you go to the Brazil country and look at the numbers, if you are looking at, so they are exploiting most of their brew water footprint because their climatic conditions are so much aligned with coffee production. They should be looking at, if we were talking about virtual water being exported to different countries, is it that's sustainable to export coffee by exploiting the blue water footprint is what they have to look at as a policy decision. They also have to look at uh, not for all the seasons the water availability would be the same, right? We would be looking at another problem where we are talking about the rice export, where we would talk about how it's not the same throughout the place, same throughout the years. We will dwell into that later. We'll park the discussion now. Next discussion would be a sustainable analyst. Third question, a sustainable analyst want to compare total national water usage for India for different sectors and which sector contributes to most of the water stress. You can head to the same website, click water assessment tool and click in country and then India. Look for India and then you can look for this pie chart. We are looking at the blue water footprint over here for India. So most of our water, the surface and groundwater is being used for wheat and rice production, the staple crop that we have as a meal, followed by sugarcane, yeah, cotton, because we are exporting a lot, and some domestic and industrial use and the other components contribute to 19.9%. So you know, yeah. Because of this high production rate, yeah. So you now know what is contributing to the most of the blue water footprint in India. This will take us to the next question. So you now know that rice and wheat are the most blue water footprint acquiring sectors in India. And now people are also becoming more conscious about their health and policy, and also the climate activists are making a hue and cry about the water stress that we're having. So a policy is going to come through, and also Indian farmers are seeing this as a market opportunity, and they wanted to now shift from rice and wheat based cultivation to millet based cultivation. If that change happens in real, what would be the change in water stress for India? That's the problem about blue water stress. So I have given some approximation numbers over here. Assume that wheat now has 30.5 million hectares under cultivation, rice is 44 million hectares, and millets, all types combined, it's 14 million hectares. So if this wheat and rice cultivation area, if it changes to millets, what would be? No, it would be the same area, but instead of wheat and rice, they are going to cultivate millet. So the hypothetical situation that we are going to work upon here is we have three areas under cultivation: wheat, millet, rice, right? So the millet production area is going to stay the same, and we are now going to convert whatever is being cultivated for wheat and rice. We are, yes, add on to whatever it is for millets. So instead of 14 million hectares, we are going to see 75 plus 14, 89 million hectares just under millets. It's a matter of math. So I'm going to head to again India statistics and then look at the water footprint. So wheat blue water footprint is 89 into 10 power 9. Rice is 58 into 10 power 9. Whereas millets, we learned from our earlier example that we just cannot deduct and do that, but we have to convert it into tonnage per hectare or ton. 41 into 10 power 9 meter cube per year. This is the total. You have the bifurcation for gray, blue, and green. So the idealistic steps would be to convert the water footprint in per year into per hectare and then multiply it with the new area that has been added and get the difference of previous versus now.